Okay, finally, example 6. We have, once again, hey, two triangles in a problem. Probably similar triangles happening here. And again, we have to get to this idea of which ones are equal, which angles are equal. First off, before I do anything about parallel lines, this angle is going to be equal to this angle. Why?
Vertical angles.
Vertical angles are equal. Anytime you have two lines intersecting, the angles across each other, the intersection, are going to be equal to each other, which means 4 is a corresponding side to n. All right, continuing on. I've got parallel lines right here and right here. Those lines are parallel to each other. And this transversal, I picked that one there, goes to the two parallel lines, right? So again, focus on two parallel lines cut by a transversal. There's two transversals. There's this one going this way and this one going that way. All right? Focus on one of those two transversals. The acute angle up in this corner has to match the acute angle down in that corner. Again, it's very important you get the correct angles identified that are equal to each other. So 5 and 8 are opposite those equal angles. And once I know that these angles are equal and these angles are equal, I can do the transversal on the other one also, but I also know two angles equal to two angles means the third angles have to be equal. And that gets me that m corresponds to 7. All right. So once again, here's another application of parallel lines cut by transversals to get equal angles in triangles for a similar triangle problem. Once again, proportions are workable on this problem. If you prefer to use scale factor, just to be different, I'm going to use scale factor this time. And something happens in this problem when you go to scale factor that hasn't happened yet, so I want to bring this to your attention. In case you're a big fan of scale factor, maybe you want to also be a big fan of proportions sometimes. It's up to you. I'll give you what I noticed about this problem right off the bat that tells me scale factor is not as easy as proportions. It'll still work, it's just not as easy. But let me just, I'll do a scale factor way though. I'm going to call this my start triangle, and this is my end triangle. It doesn't matter which one's which, just make a decision though. The two sides I need to work with to use scale factor would be the 5 and the 8 because I know both measures, right? The way scale factor has worked and always will work is that you take your starting measure multiplied by an unknown scale factor equals your ending measure. If you're going to use scale factor, that's how you begin the process. 5 beginning number times scale factor we don't know yet equals 8 ending number. The corresponding piece is necessary to know. Divide both sides by 5. My scale factor in this case is going to be 8 over 5. Wow. Try again. 8 over 5. There we go.
8 over 5.
Yeah. Terrible writing there. So scale factor is 8 over 5. So again, that's taking me from the left side triangle to the right side triangle. I got to multiply the left side measure times 8/5 to get a right side measure. So if I'm going for n, I got to start at 4, multiply by 8/5 to get n. So 4 times my scale factor 8/5 is equal to n. That just gets me 32 over 5 equals n, which is real simple. Worked really nicely like scale factor should work, right? Finally, if I'm looking at the blue ones, I'm going from start m to 7 end. My starting measure m times my scale factor 8/5 is equal to my ending measure of 7. Notice this time it's not number times number equals answer, it's answer times number equals number. So it creates this structure that's a little bit backwards from the other structures. Not that this is impossible to do, it's not that difficult to do even, but it is something you have to do some extra algebra with. 8 over 5 is a fractional coefficient. Reciprocal is 5 over 8. So times 5 over 8 is going to get us the answer. 7 times 5 is 35. What told me, before I even started doing scale factor, that that was going to happen was my starting triangle. I didn't have all the measures. 4, 5, m. So before I started using scale factor, I could see, oh, there's going to be a letter times my scale factor equals number, so I'm going to have to do this reciprocal thing. Okay? So if I'm going to use scale factor, if I'm a big fan of scale factor, and I want scale factor to work like this green one every time, all these should be numbers in my starting triangle. Then scale factor works just like the green one does every time. But if an object in my starting triangle is a variable, you might prefer to do proportions on that one. Proportions get you the same answer, and there's not as much reciprocating to be done, or weird facts about Algebra 1 that you haven't seen in, I don't know, we just covered that topic on Thursday last week. So probably about a year since you've seen this whole, oh, if we got a fractional coefficient, we multiply by the reciprocal. You should know it, but you haven't practiced it recently, so maybe you don't remember it. So just keep that in mind. Proportions would have worked also if I had done proportions. I'm going to put 4, 5m on top. Four corresponds to n, 5 corresponds to 8, m corresponds to 7. I cross multiply the the n part here. I get 5n equals 32. N is 32/5. If I cross multiply the m part, I get 8m equals 35. So m equals 35/8. That's the answer. That's the whole problem. Okay. Proportions. A little bit more effort, maybe setting up the process, the structure, but getting the answer is a little bit simpler a lot of times. So again, think about that. If my starting triangle doesn't have all numbers, then I'm probably going to go proportion every time. Going back to this one, my starting triangle would have had all numbers in it, so scale factor probably would have worked pretty easily there. Keep in mind though that 6 plus x was an unknown on that one, so maybe you don't want to be able to scale factor that scenario. That's up to you.